I'd like to work this problem with you, and it's going to be a little bit different than what we're used to working. Same concept, it's just going to vary a little bit different. So let's read our problem first. Naturally occurring magnesium has an atomic mass of 24.312 and consists of 3 isotopes. The major isotope is magnesium-24. Natural abundance is 78.99%. Okay, relative atomic mass is 23.98504. The next most abundant isotope is magnesium-26. Relative atomic mass 25.98259. The third most abundant isotope is magnesium-25. Relative atomic mass is 24.985837. What are the abundances of magnesium-25 and magnesium-27? See if we can get this to hide. It doesn't want to. No, hide. All right, well, we'll have to deal with it. All right, so first thing I'm going to do, I always do, is I box my numbers in units. It makes it just easier for me to find. Okay, you have to find, what makes this difference is you're going to have to find 2 percentages, okay? So I think what I'm going to do is I'm going to make myself a little table, and it's going to make things a little easier. I'm going to be 24 magnesium up here, 25 magnesium, and 26 magnesium. Okay, I know the atomic masses for all of them. Okay, for magnesium 24, it is going to be 23, 23.98502. Magnesium 25, that should be a 2. It didn't write real well, but 24.9853837. And for magnesium 26, we are going to have 25.982593. Okay, I know I'm going to have 78% of this. I don't know what the other 2 are. Okay, but if you remember, all percentages have to equal up to 100%. So what we can do is to figure out what the remaining 2 isotopes, what the percentage needs to be for that, is simply subtract 78.99 from 100. When you do that, you're going to get about 21% is left. So the 2 of these isotopes have to equal, okay, 22 or 21.01%. Okay, I'm going to call this one X, okay, and I'm going to turn this into a decimal because that's how we do here. 0.2101 is our decimal. Okay, so if we take this amount that is left over, 0.2101, and we minus our X from it, okay, because our whole amount has to equal 21.01%. We're going to get our remaining value. Okay, I want to really get this to auto. There we go. All right, so I'm going to set up the problem the same way that we do all of our other problems. Remember, percent abundance is mass of A times percent as a decimal plus mass of B times percent as a decimal, dot, 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 dot. It can go on forever. So I'm going to set it up that way. My first number, remember we need to turn it to a decimal. So for magnesium 24, I'm going to write 0.7899, and it's going to be times our abundance, or our mass, which is 23.98502. Plus, okay, so our next one is going to be a little different. Okay, it's going to be X, and I'm going to write a funny multiplication sign there. like a star, times our 24.985837. Okay, the next one's going to be a little weird, okay, but we need to write it like it is here. We are going to do 0.2101, and you can put that in parentheses if you want, minus x times, I'm going to leave this, well, I would put that one in parentheses. I'm going to leave this probably outside, or it might be easier to put it in. Let's put it in parentheses. 25.982593. Okay? Then we just, and that all is going to equal our magic number of, that we already know, right? It is going to equal our magic number of what our percent is. Okay? And our percent abundance is, let me see if I can find it. 24 points. That is our atomic mass. 24.3050. Okay? So now we just got to do a little math. So we're going to do a little math here. And it is going to equal this, when you get all of this together, it is going to equal 18.94578 plus 24.95837x when you multiply those together. Okay, plus we're going to get this times that. Okay, so we're going to get this times 25 is going to give us 5.459 minus 25.982593x equals 24.3050. Okay, so let's do a little combining of like terms here. I think that's probably what you call it. We'll do a little combining of like terms. All right, so let's see. I am going to, let's subtract everything from that other side. Okay, so we're going to subtract, because we need to get rid of it on the left side. So how we're going to do that is we're going to subtract it. Okay, so we're going to subtract 18.9578, and we're going to subtract 5.459. When we do that from 24.350, we should equal 0.09978, and that's going to equal our, what, 24.95837x, and our minus 25.985293x. Okay, get x by itself. You're going to subtract those. Okay, and you should end up with 0.998x equals 0.09978. Okay, all I did was I just subtracted 24, or added 24.9537x to the other. Okay, just combined like terms. Now, to be able to get rid of that, what we need to do is divide it out. Okay, and x is going to equal, hopefully my math is correct, 0.09978. Okay, that is going to equal your x. Okay, so let's do the next part. All right, so now that we found our x, we need to turn that into a percent again. We're going to multiply it by a 100. But what I'm going to do is I'm just going to round it up. You can do that. Okay, so we know that we have to equal 21%. That is what is left over from the 78.99% up there. Okay, so if this is going to be 10%, let me write that better for you. That's pretty bad penmanship. Okay, so if this is going to be 10%, okay, and we have 21%, that means that this is going to be 11.101% roughly. Okay, and that would be how you would work that problem. Easy peasy lemon squeezy.